Let's talk about polynomial functions. First of all, what is a polynomial function? A polynomial function is a function where x is raised to a whole number power. For example, if I've got f of x equals 3x squared plus 2x minus 4. This is a polynomial function. X is always going to have a positive whole number exponent. No negatives, no fraction exponents. Another example, by the way, this one right here is quadratic. You guys should be familiar with that one. Second power is quadratic. I could have f of x is equal to negative 2x to the third power plus 10. This is a polynomial function. F of x equals 7x minus 5 is polynomial. I know it looks like x is not raised to a power here, but I could put 1 as an exponent and it does not change the value of that function, of that equation. Okay. Sometimes when we're talking about what something is, it helps to talk about what something is not. So let's talk about things that are not polynomial functions. X cannot be in the denominator of anything. So if I've got 2 over x plus 9, this is not. X cannot be down in the denominator. F of x is equal to the square root of x minus 3 is not. X cannot be in a root box. F of x equal to 3 to the x power. X cannot be the exponent in a polynomial function. Also, we talked about how the exponent has to be a whole number. So I can't have f of x where it's x to the negative 2. Or I can't have f of x is equal to x to the 3/4. Okay, those would not be polynomial functions. Okay. Every polynomial function has a degree. The degree of a polynomial function is the value of the highest exponent. Okay, so let's see. I can't write as fast as I talk. If I've got f of x equals 3x to the 5th minus 2x to the 3rd, okay? This 5 is the highest exponent, so this is a 5th degree polynomial. Okay, I've got f of x equals 2x squared plus 7x to the 4th minus 6x. Okay, I look for the highest exponent. Right there, it's a 4. So this is a 4th degree polynomial. Okay. I purposely wrote this one in the wrong order. Let's talk about how these are properly written. This is not wrong. It's still a 4th degree polynomial. But when you see these written and when you write them yourself, you're typically going to write them in the order of the highest exponent first, the term with the highest exponent, and then in descending order from there. So the proper way that this one should be written would be this one first, 7x to the 4th, then this one would be next, plus 2x squared, and then this x that would have a 1 right there would be minus 6x. Okay, it's important to know the order of this because we need to know something about that lead coefficient. We'll talk about that on the next page, but positive 7 right here would be the lead coefficient of this one. 2 is the lead coefficient of this one. 3 is the lead coefficient of this one. Okay, in talking about these lead coefficients, let's talk about what the graphs of these look like. Okay, if my lead coefficient is positive or negative, or when that lead coefficient is positive or negative, that helps me determine some things about the graph as far as on the ends. When we talk about end behavior, remember we're talking about the left end side of the graph and the right side of the graph, okay? So if my lead coefficient is positive, okay. Okay, that's a positive. Then I know that the right side is pointing upwards. Okay? If the lead coefficient is negative, I know that the right side is pointing downwards. Okay, this is the right side only. Okay, when we're talking about the degrees can help me to determine what's happening with the end behavior also. Okay, if I have an even degreed polynomial, okay, then I know, let me put that in a different color. If I have an even degree polynomial, then I know that both ends, the right end and the left end, are going to point in the same direction. So if it's an even degree, left and right point in same direction. Okay? On the other hand, if it's an odd degreed polynomial, then I know that the left and the right are going to point in opposite directions. Okay, we'll look at some of these in a minute. Okay. Odd, opposite. Okay, now that degree can tell me something about how many relative maximums and minimums a graph will have. In the papers that we've done, they call those bins. Just remember that a relative maximum or a minimum is actually the graph changing directions. Okay, so if it's going up and then it turns to going down, then this is what we refer to as a maximum. Okay, it was going up, now it's going down, it has changed directions, it's a maximum. Okay, also, if that graph was going down and then it turns to go up, okay, we refer to that as a minimum. When we talk about bins, this is what we're talking about. Okay, so the number of bins, generally, so in general, you know, in general means a lot of the time. So in general, the number of bins is equal to the degree minus 1. Okay, that is in general. That is the maximum number of bins. So let's call that the maximum number of bins. Oh, that might can. Let's say the most bins. I don't want y'all to get confused with the maximum. Okay, and then from there, it decreases by 2. So let's look up here and do a few. Okay, if it's quadratic, it's second degree. Okay, if it's second degree, then the number of bins is going to be 1. Okay, 2 minus 1 is 1. If the lead coefficient is positive, then my graph is going to look somewhat like this on the ends. Both ends are going to be going up. If the lead coefficient is negative, then both ends are going to be going down because it's an even degree. Okay, cubic, third degree, let me just put right there, 2 minus 1. Third degree, 3 minus 1 is going to be 2 bins, okay, or it could be 0 bins. Okay, a cubic could look like this, where there's no bins, okay. It could also look like this, where I've got 1, 2 bins, okay. If the lead coefficient is positive, I know that this side over here is going up. And since it's an odd number, they're going to go in opposite directions, so this one's going to go down. If the lead coefficient is negative, the right side is going down, the left side is going up. Okay, quartic. This is probably a new one for you this year. Quartic is a 4th degree polynomial. So 4 minus 1, I could have at most 3 bins. Or if I decrease that by 2, there could just be 1 bin. Okay, so this one could look like this, kind of like a parabola, but it's a little bit more U-shaped. Or it could give me any kind of like W or M. It could be flipped upside down. 1, 2, 3. So lead coefficient positive. Both ends are going to go up. Lead coefficient negative. Both ends are going to go down. 5th degree. 5 minus 1, that means the most bins it's going to have is 4. We could go down to 2, or it could have 0. So 5th degree in its purest form is going to look almost exactly like cubic, but it actually gets a little bit flatter or wider as those degrees get higher. It could look like this. It could look like this. See if I can get them all in there. Okay? So, once again, it is odd, so the ends are going to go in opposite direction. Positive lead coefficient means the right side is pointing down, left side up. Negative lead coefficient, right side, oops, I did that backwards. Positive lead coefficient, right side is pointing up, left side is pointing down. Negative lead coefficient, right side is pointing down, left side is pointing up. Okay? I'm going to do one more with you, and if you want to fill in the rest of those, you can. So 6th degree, here we go, 6 minus 1. At most, there will be 5 bins. I'm not even going to try to draw this one for you. There could be 3, or there could be 1. Even degree, the ends are going to go in the same direction. Positive, they're going to both be pointing up. Negative, they're going to both be pointing down. Okay. Make sure that you ask me about this in class if you're still confused about any of it. Let's just look at a couple of examples, and then we'll be done. Okay, so let's say that I've got something that looks like this. Okay. I want to know what is the possible degree of this function, and what is the lead coefficient doing. So let's count the bins. I've got 1, 2, 3, 4, 5, which means this is at least 5 plus 1, a 6th degree polynomial, at least. Okay, it could be 8th or 10th, etc. Okay, but we know that it is at least a 6th degree polynomial. The right end is pointing down, so I know that I have a negative lead coefficient. Okay, so now then, let's do one where I give us the information and we draw it. Let's say that I have got a, let's see, how about a 5th degree, with a positive lead coefficient. Okay, what I know for sure on here is that it could have 4 bins. 5 minus 1. Okay, it could have 4 bins. Okay, it could have 2, or it could have 0. Okay, any of those are possible. I'm going to go ahead and do this one though. Okay, and because it's 5th degree, I know that those ends point in opposite directions. Since it's a positive lead, I know the right end is going up. That means this end has to go down. Okay, let's sketch that real quick and then I'll be done. So here we go. Let's see. See if I can get 4 bins in here. 1, 2, 3, 4. Okay, that is possibly what a 5th degree polynomial looks like. Okay, we'll get in more into this week. Please don't forget to ask questions in class if you're not understanding.